So what we are going to talk about today is number talks. And along with that, building numerical reasoning. A lot of discussions are happening these days that our kids are not doing very well in mathematics. And there are some issues regarding not knowing their basic facts and not knowing their multiplicative basic facts, etc. Important thing that we need to realize is we in our classrooms, we need to give exposure to kids to understand the conceptual learning first, then go to procedural. And of course, I do agree with basic facts are important. We do need to have the rote learning, but the rote learning cannot come before conceptual learning is developed. And that's how I think this the number talks are very important for us to develop that just a basic and conceptual understanding for kids and revisit that again and again the 5 minutes in the morning that we do. And that is what number talks are all about. So let's talk about what they are. So today's session, we are going to talk about number talks, also mathematical fluency, and we are looking at how do we build up the reasoning that the kids need to have. And the reasoning needs to be allowing the kids to have the safe environment and also think about whether I agree or I disagree, and I have all those talk modes that develops the mathematical understanding and reasoning. So number talk is a short, ongoing daily routine that provides students with meaningful, ongoing practice with computation. And number talks should be structured as short sessions alongside, not necessarily directly related to the your task that you're going to do, but it could be nonetheless. It could be joined, it may not be, but that is a little warm-up where we want our kids to start thinking and having a discourse. Very important thing here is kids are talking to each other. They are listening to somebody else's answers or strategies or thinking and allowing them to agree or disagree with somebody else's thinking or their own thinking. What are the goals of number talks? Of course, it is to develop computational fluency, but they need to understand that numbers are composed of smaller numbers. So if you talk about any number that we'll give you a lot of examples and thinking about that how numbers are subdivided, they have relationships within each other, they have relationships with each other, and numbers can be taken apart and combined with other numbers to make new numbers. We also know that one number can help us to figure out other numbers. If we know some other numbers, then we can connect it with other numbers and make some bigger numbers or smaller numbers. What we know about parts of small numbers can help us parts of the larger numbers. All these understanding that we need to allow the kids to have while we are looking at, even if we are looking at number 2 or number 3 to start with, they need to think about what is the relationship between 2 and 3? Why is one bigger? Why is one smaller? What makes one bigger? What makes another smaller? All those relationships start from year 1. Teachers do not teach specific strategies to the children during number talks. Somehow or the other, we have learned, or as teachers, we've developed that we teach to a strategy, which may be harmful in certain ways because the kids have so many different strategies that they are thinking about, and valuing those that your strategy works for you, and that's very meaningful. And that is what number talks allows us to do. And because it's children think for themselves and use the mathematics they determine is most applicable to the problem at hand. They need to be fluent in using those strategies. So our role as teachers is to provide a safe environment where child can think safely and the child's thinking is valued. Teacher selects group of strings of problems that allow access to all children. That is another important thing, that we want all children to be considered as equal, and that equity is developed through number talks. Teacher selects problem that intentionally highlight mathematical concepts. Teacher values everyone's thinking, focuses on how children get their answers. Teacher provides adequate wait time. Not the person who thinks first gets a chance to answer first. So what we think about is have a wait time, allow everyone to think about it first, and then they talk amongst each other and then start working, okay? Shifts the focus from see what I see or what do you see? So the teacher is allowing the ownership on child now, that what do you see rather than what I want you to see or what I see. And she records, clarifies, reads, states, and that is important. Every child's answers or thinking needs to be recorded through number talks. Realizes that if a child or children do not get it, then it is the teacher's responsibility to figure out the misconceptions or lack of proficiency and to begin instruction at that point. I just want you to have a little think about within yourselves. I don't have time here for interaction, but we would like to think about that. Do you view mathematics as a collection of rules and procedures to memorize, or you think it is a system of relationships to investigate and understand? As teachers, we need to dive deep into what mathematical concepts are and think about how we allow the kids to investigate, understand the relationships. So the question here is, how can educators make shifts in their instructional practices that foster sense-making in mathematics? But before we go there, I want you to think about what is mathematical fluency. If you look at the curriculum, most of the time the kids are supposed to be fluent, and we want the fluency in kids to solve problems. Now, fluency has three parts. One is accuracy, efficiency, and flexibility. So when you think about what is accuracy, it denotes to the ability to produce an accurate answer. Efficiency denotes the ability to choose an appropriate expedient strategy for a specific computation problem. And flexibility refers to the ability to use number relationships with ease in computation. People, we want to think about all combination of all three together that makes a child fluent. Not only accuracy, not only efficiency, but more so of flexibility that we require. And we are just going to have an example for the same. This is what we're looking at. When it's one number given to us like this, 199 plus 199, and quite a few people, quite a few parents who have learned this particular way, I'll think about that this is the way we need to do, because that's the way they know. Some of the teachers think this is the best way to know because they know it. But think about if the numbers are so fluid, 199 and 199, the child can think is, oh, I know it's 200 and 200. That makes it 400, and I'm just adding two more. So I take away two, which makes it 398, which makes a child more fluent in mathematical thinking, develops a number sense. I'll give you another example, which I generally use for my parent evening. And I give them the question that is 2,000 take away 1,998. What is the understanding that we want the kids to develop? If the child does 2,000 using the column 1,998 and think about, oh, I need to borrow, there is 9 here and there's 9 here and I'm borrowing 10 here, and then I write the answer, oh, this is just 2, okay? Because this is all 0. If the child does that and thinks about, oh, these two numbers have relationships as just two numbers apart, rather than going through this procedural understanding. This is procedural. And if the child thinks about that, oh, it's just 2 numbers away and the difference is just 2, that is what we want. That is flexibility in thinking, and that is developing number sense. So I'm not against algorithm, which is, it has its own place, But when the numbers have relationships which can be easily detected or visualized, that is what we want our kids or think kids to develop within our learning. Okay. So let's take an example. If you think about 12 divided by 3, people will start thinking, what is the best way to acknowledge or write or read this equation? And we say, you're really actually asking is what? How many 3s are in 12? And that's what is the importance about division. How many 3s are in 12? The same thing is with division of fractions. So half divided by a quarter shouldn't be very difficult if you can easily say it or read it as how many quarters are there in half? And the kids can easily understand that if there are only 2. So it is our developing that understanding for the kids by asking questions in a way they can easily understand and visualize that. How do you visualize how many quarters are there in half? So fluency is a byproduct of flexibility, and I just want you to read it. But I really feel that why do we want to be ineffective and inefficient in teaching rather than using, just take the anxiety part away from the kids and allow them to understand, learn, and of course, maybe rote learn later. Visuals are important. I'm just going to skip through some of my slides, but if you can get the idea, understanding the relationship is the best way to think about flexibility. Right, I'm going to show you some of this wonderful video clip by Kathy Humphrey and Ruth Parker, and they are talking about what number talk means to them. And I would share that with you just in a minute. Tell me if you can, Mala, I would like you to see whether you can hear that, okay? Because sometimes we can't hear.
Yeah, I'll let you know.
Number talks are a safe space bounded by about 15 minutes a day.
I can hear.
Where students of all ages have opportunities to not only learn about number, but learn, more importantly maybe, that they have mathematical ideas worth listening to, and that mathematics makes sense, and that they can make sense of it in their own ways. And the conversations that happen around those diverse ways of seeing that kids solve problems, I think, deepen understandings for all of the students in the classroom, and they deepen the mathematical understandings of the teachers as well. It turns on its head the way we've always thought about teaching arithmetic, but in its place, instead of children with a very fragile understanding of number, we end up with students who really understand numbers and computations and the relationships involved and why they work.
I first realized how important number talks could be for them, and so wanted to use them with older students. But then I realized that as they were starting to make sense for themselves, they also were using mathematical practices, almost every single mathematical practice in the process of doing a number talk, and they were developing one of the most important aspects of being powerful mathematically by starting to take on the agency for their own learning. The baggage that kids bring when they're older of not being good at math, not feeling good about themselves, vanishes when all they have to do is figure out what they see. And then through that, looking at the different ways people see, they realize that people have different ways of thinking about math, and they learn to explain their reasoning in a very safe setting.
I've also had opportunities to use dot cards with high school students who had histories of failure in mathematics, and the power that happens in terms of students being willing to carry the discourse in a classroom is I think, thrilling, and I haven't found any other instructional strategy that gets them there. And I do think at the essence of that is it's a topic where they don't have to bring all their math injuries and math fears. It's just, what do you see? One girl described it for us as, she said, I used to feel like I was the dumb kid in math. Everybody was getting things that I wasn't getting. And I learned through this that I really can see things in math my own way, and that's okay. And in seeing things my own way, I realized I can do math, and sometimes I even get things before other people around me. So the payoff is just comes in so many different ways to students and I think to teachers. It brings the joy back into teaching.
Okay. It has a lot of value, people. Number talks are really wonderful. And the book that she suggests is really wonderful. They have written it together, and it's a wonderful book to refer to as well. You can see my slides now, Mala. Mala, can you see my slides now?
Yeah, that's fine.
Okay.
Yes, I can see. I can see.
Thank you. And so we will be starting with exactly what the video clip was talking about, is subitizing. So I'm going to show you a slide with some dots on it. I want you to, and I'll give you some time. I want you to think about how do you see it? And this is how I would do with my kids. So what do you see? And if you see one way, I would like you to put a thumb up like that and wait. If I see another way, I see another way. I see. So keep on thinking if you can see different ways. But why is that waiting time important? Because there could be some people who process things slightly slowly. That doesn't mean that they are not mathematical thinkers, but we are giving them the chance to think their way as well. So I'm going to give you some time to think different ways, and then I'll just talk about what my kids in my classroom have done. I'm going to show some computations or slides with juniors as well as seniors, because I'm aware that there are people with variety of age teaching groups over here. So we'll start with, say, juniors who are starting with just number 7. I'm not looking at counting the dot one by one. So I would encourage children that I'm not looking at the answer, how many dots are there. I'm just encouraging you to see how many dots can you see as groups, or how do you see these groups? Just keep thinking, keep watching, and keep doing the way you can. Right here. I'm very sure that you might have thought about it in different ways. I can't get your answers. Generally, I would like you people to think about how you are talking about, but I'm going to just suggest some of my kids what they did. And I would say that she said that I could see 2, and I could see 3, and I would see 2 here. And I would write the name of the child, and that child is Bina. Okay, so I would say Bina sees it this way. And somebody else say, okay, Mala is seeing this way. I can see 3 here, and I can see 3 over here, and I see 1 over here. And I would write the name right now. And so on. And this one, this child over here is saying, I can see 2 this way, and I can see 2 this way, and 3 this way. And then, so that is the way I see it. There's one child who suggested I can see 1 here, and I can see 5 here, and then I can see 1 here. Another child says that I could see 3 here, and I could see 4 here. And one of the child had just said that I can see 2 this way, I can see 2 this way, and I can see this. I do this for year 1s, year 2s, and even older kids. And but this is amazing to see how they see in variety of ways. But at the same time, we are not looking at just visualizing. We're also looking at how do I write that? I would say I can see 2 plus 3 and 2, and 3 plus 1 plus 3, allowing them to see that 7 can be written in different ways, but there is a similarity as well. how many kids are looking at the same equation here? And the kids would say, the Bina and somebody else, and the last person is looking at 2 plus 3 plus 2, but they are saying it in different ways. Allowing the kids to think about that there could be various ways of looking at the same number at the same time. We don't see those kids who are little not confident about mathematics. They can also see these dots and they can visualize and they can connect it together. If I look at the seniors, and if I give them this particular slide, and I would say that I would like you to think about that. How do you see these dots? I don't want you to count every dot, but how many dots are there all together? How do you group them? So I'm going to give you a few seconds to think about that. Okay, so in my class, I had people thinking that way. And the first person or one person said that I could see 3 groups of 6 here. I would see 1 group of 6 here. And I would probably write that down in this particular fashion. And I would say 3 groups of 6 plus 3 groups of 2. But at the same time, I can put the question out that if I see 3 groups of 6 and 1 more groups of 6, what can I write mathematically? And they would have a turn and talk, they would have discussion, and that could be 4 groups of 6. We are allowing that mathematical multiplicative thinking to develop over here. The second child has seen it this way. And the third child has seen it. This is quite an interesting way of looking at things as well. And I see quite a few adults would also think that way. I can see 2 groups of 3, which are missing. But at the same time, I know 6 groups of 6. There are 36. And I would take away 6 from here. And there are 30 dots altogether. What are we encouraging the kids to see here? We are encouraging kids to look at multiplication in different ways and not only just having rote learning. But this is very important to do many times for kids to think about how many ways can I say 6 or arrays of numbers that make 6, okay? Or 3s. Similarly, what do you see this as? And the child would say that I can see 5 groups of 4, and that would be, 4 groups of 5, and that would be 20. And I would say, if I give you another slide, this is what do you see now? We are less looking at where a child can see 1 group taken away. So I can see 3 groups of 5. How do I write that? I can write 3 groups of 5 and take away 5, or I can also see 20, which was initial, and take away 5, which is 15. Allowing kids to see or visualize that in variety of ways to come to an answer. Okay. Is there any question? No? Okay. So we are looking at flow of communication. We want the kids to have a lot of thinking amongst themselves, a lot of discussions amongst themselves. So before they talk to the teacher or to the wider group, then they have initial understanding and discourse amongst themselves as well. I would also like you to look at this particular conversation. This is what I do for number talks as well, but this is statistics, but allowing that understanding of what you notice and what you wonder. It is a discourse that we want the kids to develop before or warming up, before we start any session, right? So I would share that with you right now. Very sure it's here. Sorry, where is it gone?
Take a look at your graph.
In most classes, variability is not the exception.
We're going to be doing an I notice, I wonder.
this teacher is aware that these children learn at different paces. And so she is creating a mechanism to see the developmental starting points of a diverse group of kids so that children can move at different rates to master the content.
This classroom is heterogeneously grouped. This is a non-tracked class. Some kids will be bypassing Algebra 1 next year and going into an advanced class, and some kids will be taking a pre-algebra class. So there's a wide range. Today's graph had a lot of information in it, and so it was perfect for an I notice, I wonder.
What is this graph telling us? What do you notice in the graph? Don't do the wonders yet, just your notices. Take about 2 minutes.
The I notice, I wonder helps kids slow down and really focus on what's in front of them. They wrote about what they noticed and then turned and talked to a neighbor to enhance and to draw attention to things that they maybe had missed.
Renewable energy aren't being used as much.
Yeah, seems to be going down actually.
The information she is getting is about the individual variability in that classroom. What the kids are getting is the benefit of learning from each other.
All right, let's get a list of I notice and I wonder.
I noticed that petroleum had a big jump in the 1900s.
It's another notice.
I noticed this is a monthly energy review.
Oh, so you're looking below the graph as well as above the graph. Awesome. All right, let's switch over to the back side, and I want your wonders. What do I wonder about this graph?
The I wonder is a great way for me to see what they need to know.
So what do you wonder? Oh my gosh, so much to wonder about.
I wonder what the other renewables are.
It's also a time when you can build confidence in kids.
Great question.
Yeah.
Yeah, I agree with you. Aiden,
What is BTU?
what is a BTU? Great question.
I notice, I wonder just brings the conversation to a place where all people can contribute. It gives everyone a voice. It allows kids to listen to other people's ideas before they do the analysis. So it's like a way to collect information collaboratively, but allowing time to think first.
Right here, I feel that I'm just rushing and not allowing you to have any conversation with me, but I think that's the way it goes. And where is my PowerPoint? Okay, hope you enjoyed that. And this is, I think, I have introduced that to many, many schools that I notice, I wonder, starting with year ones. The teachers, after a few months, have been just so enthusiastic about it and said, my kids are talking. My kids are saying so many different things that I would like them to talk about. And it's just amazing. There is such a lot of energy in the classroom, which is amazing. So try, if you're not doing that, try doing that as well. And that also creates reasoning in the classroom. People, I'm just looking at the time and thinking about it's rushing. So just think about students develop an increasingly sophisticated capacity for logical thought and action, such as analyzing, proving, evaluating, explaining, inferring, justifying, generalizing. This is what mathematics is all about. And we want our kids to think critically whenever there's a question, not just for the sake of doing it, but finding out, why am I doing it? How am I going to prove it? How am I going to justify and generalize out of this? That is what mathematicians do. So encourage that happening. And I will skip through that. And I'll probably think about what else belongs over here. There are 3 numbers. What relationships these numbers would have? What other numbers would belong in this particular category? If that is a question asked to the kids, this is what my kids have said. And the kids have said they are even numbers. Yeah, some of them said they are 2-digit numbers. That's great. What are the other things that can make it, what are the other relationships? Some of them say they are all multiples of 3. Okay, and how do you prove that? How do you justify that? Do we all agree? Do we all disagree with that? And thinking further, And somebody said that they are all multiples of 2. Do we agree? Do we disagree? How do you prove it? How do you justify? Turn and talk to your partners. And somebody said multiples of 6. If you can think about something else, just write in your chat, because I will be able to get the chat later on. So continue writing your chat and I will get a lot of understanding of what you people have understood out of that. How many different numbers can be part of that? All right. This was quite interesting when I asked my kids, which one doesn't belong? Which number doesn't belong? There's so many different ways of looking at it. So anybody can be part of this conversation. You don't have to be considered the best mathematician in the classroom, but anybody who doesn't have the confidence also will come in and start talking about it. And somebody says, oh, 9 is not included because it's only single digit number. Somebody else said 43 is not included because others are square numbers. Someone said 9 is not included because if you add the 2 digits of the other numbers, 1 and 6, 4 and 3, 2 and 5, they all add up to 7. And that was quite an amazing thing. What kind of noticing these kids are doing, what kind of thinking these kids have. It's just amazing to see what ways are we encouraging this number talk happening. Another way of introducing number talk or number talks is true and false. Starting with little ones, 6 plus 6 is the same as 7 plus 5. Do we agree? Do we disagree? How do we prove it? Is it true? Is it false? The kids have to show it in a variety of ways. Some of the kids would say that, okay, we can show it through number frame, in tens frame. But there's another way of, there are many, and I think I have had one class and when the child was looking at the relationship. So this is 1 plus, 1 more here, and this is 1 minus here. There's a relationship between 6 and 7 and 6 and 5. So if I take 1 away from here and I add 1 over here, then it becomes 6 and 6. So that's one beautiful way of looking at. These are little kids. We're looking at your 1s, your 2s, your 3s, and they come out with such wonderful relationships, which we want to encourage so that they can be fluent later on. Another idea about number talk is, what do you see? How do you see this number? What is the relationship? How would you get the idea of how do you solve this problem? Just giving you some time to think about why you're going to solve, how do your kids do it? But I've got some examples here and see that, oh, wow, this is not really. One of my kids in the classroom said 30 plus 40 is equal to 70, 7 plus 4 is 11, and 70 plus 11 is 281. Another child would say 40 plus 40 is 80, and 80 plus 1. Where do you see 40 plus 40 is 80? And we think about how does he get that idea of 40? And if I don't understand as a child, and he's sharing it with a wider group, I have the chance to ask, I don't understand, how do you get the 40 here? And then he would explain in whatever way he would like to, and that's amazing. And somebody said 37 plus 40 is 77, 77 plus 1 is 4 is 81. This child, and we can now think about that what might the child have taken over here, that 37 plus 3. So equation, making it equal by just taking 3, adding 3 and taking away 3 from the same equation. And it's 81. Variety of ways. Another one said I can use number line. I can start from 37 and then add and then come to 41. That's 81. And that's how I can justify what others are thinking. And that was a wonderful way of looking at it, that how do you justify what somebody else, this is an example from my classroom. And that was quite interesting to see that I wouldn't say that this was what one of the last one, the number line one, I thought was very interesting to see how he was able to justify that what others were thinking is making sense. This one I have used many, many times. And it's a number talk which allows the kids to think about what can you see? What do you wonder about? And the kids are saying, I can see 63 written in a variety of ways. And my next question for these kids are, that I'm going to add 2 more to this puzzle. So I want to have 2 more different ideas about how do you make 63, and the kids would come out with different ideas and tell me different ways of making 63. People, I want you to really pay attention to this part, that this is quite important. If the kids can see 63 as 50 plus 13, it is actually encouraging our kids to think about algorithm. Or if I would say 63, I'd want to take away 7, what do I need to do? The kids do not see 63 as a whole number. They would say, oh, 7 cannot go from 3. Now that 3 is not just 3. We are looking at 63. So 7 needs to be subtracted from the big number that is 63. And that's why this understanding of 50 and 13 is important. That what am I going to do? I'm renaming this. I'm renaming as 50 and 13. And that's what the kids need to understand if they want to do algorithm. Then they can answer whatever. 7, I can take 7, take it from 13, and that would be 6, and that would be 50. So it would be 56. But it's important for kids to see that number 63 in variety of ways to be able to compute any further computations that they need to do along with it. I probably wouldn't show you this because I'm almost at the end of, but choral counting is wonderful. And what is choral counting? It takes a little longer. I want you to think about this. That could be probably my last thinking. I want you to think about how do you say 18 multiplied by 5? And kids come out with a variety of ways. There's a wonderful video clip by Joe Bowler, which I have attached over here, which you probably can see, or if you can't see, go to U-Cubed, and you will be able to see what this is all about. But I can show you picture visualization of that number is this. So if somebody did say 18 times 5, as I can see 9 times 5 and 9 times 5, that is 4. This is 9 times 5 and 9 times 5. And that is 45 plus 45, which is 90. How do you show that? This is 9 times 5, which is 45 here, and 45. This is also connecting with further of area and other metrics that we could do with the kids would be able to do when they are older. And 18 times, so that is 18 times 5 and 8, 9. So you're doing it halving and doubling. So 9 times 10. How does it look like? How does it represent? This is what generally people do. 10 times 5 and 8 times 5. So this is 40 and 50, and that's, some of them would do that as well. 5 times 20, and then take away 2 lots of 5. But visualization is important. 15 and 3, I would do 15 times 5, I wonder, but some people do that. And one person has looking at splitting that 5. So what he's looking at is 18 times 2, 18 times 2, and 18 times 1. He has split that 5 into 2, 2, and 1. But that is an amazing way of looking at it. We generally don't see our kids splitting those numbers in that particular way. And Joe Bowler has really, really emphasized on visualization, that how important it is for us to think about. So my whole idea of this number talks today was allowing a mixed ability grouping where people are listening to each other's idea, because mathematically, or I would say intellectually, all our kids can learn. Only thing they haven't been able to learn so far is due to their experiences are not good enough in mathematics, and they haven't got enough confidence. And if kids learn from each other, their confidence really, really develop further. So I'm going to actually end my talk right now. And we'll just look at I've got lots of slides, but I just want you to think about what was your learning today. And if you can just put that your learning in just a chat, that I would love to see what was your learning today. It would be really wonderful to just put a couple of ideas that you think it was your learning today.
Thanks, Bina. There is a question from Kim Meredith.
Yep.
She wants to know how you use the pen to write on the slides. In fact, I would like to know that too.
Okay, I've got wonderful equipment called Wacom here, WACOM, and it has a pen here. So I need to connect this with my laptop, which is very easy. It just has its instruction, and I write on this, and which will go on my slides over there.
I see. So you cannot use a pen through your mouse and then draw on the slide. Is that?
I can't do it, but some of the PC computers can do. Mine is Apple, doesn't allow me to do that.
So Kim, does that answer your question? Yeah, I think, and let me have a look at the other questions. So there are some comments as well. Some learnings are that slow down and get the children to talk and think, and they like the subitizing idea, and increasing confidence and conceptual understanding is what someone got out of it. And that's Anne. And love the idea of getting the children to show how many different ideas. So I'm just looking for a question, and there's I notice, I wonder. So I think a lot of those are comments. What we got out of this is a whole lot of ideas, Bina. And what you're saying is absolutely true, that we need to build the mathematical fluency by introducing a conceptual idea first, and then moving on to the procedures, and before coming back to more multiplicative thinking or reasoning. And the build up with those dots were really good to increase students' multiplicative thinking and the number talk. And you've given us lots of ideas, lots of things to think about with I notice and I wonder, those videos, and then the jigsaw, and then true or false, choral chanting, all of that is great. And I particularly, my big takeaway was, apart from which one doesn't belong, you've asked the question, what else belongs? And I think that's a wonderful question that we can use in all different number talks. There is a single, there's a question from Yvonne. She says, she's asking, how often would you aim to do a number talk in a week?
Every day for 5 to 7 minutes in the morning. I mean, just before the class, before my task begins, because before my guided teaching begins, I have 5 to 7 minutes every day.
5 to 7 minutes. Yeah. I think that was the question. And everybody likes the subitizing idea. I like it too, and how it can lead to reasoning and multiplicative thinking.